Hey everyone, welcome back to your search buddy. In our previous video, we have talked about the wave function. Now let's talk about the Schrodinger's wave equation or Schrodinger's equations. So Schrodinger's equation is a mathematical expression which describes the change in physical quantity over time. Okay, and change in physical quantity over time we always consider in case of quantum mechanics, and we know that wave function having four coordinates x, y, z and t. It means by using this wave function, by analyzing the change in this wave function over time, we can found the most important properties of any system, right? So Schrodinger equation is a mathematical expression which describes the change in physical quantity over time, in which the quantum effects like wave particle duality are significant, right? It means we can find out more information about wave particle duality by using this Schrodinger's equation, right? And these Schrodinger's equations has two forms. One is time dependent Schrodinger's equations, and second one is time independent Schrodinger's equation. Okay, so let's start with first one, that is time dependent Schrodinger's equation. All right, we know that, or it was observed that the wave function of a particle of fixed energy E could most naturally be written as a linear combination of wave functions of the form psi. We are taking change in this wave function along only one direction is equals to a exponential iota kx minus omega t. Alright, this equation representing the linear combination of all the wave function. As we know that wave packet is always two or more waves are superimposing with each other, they will form a wave packet. And the wave packet, or the linear combination of all the wave functions within this wave packet, can be written as psi rt, or if you are taking change along only x-axis, for our own convenience we are taking only one dimension and then we can convert it into three dimension. So we are taking change only along x-axis, then it will be psi xt is equals to a exponential iota kx minus omega t, where k is the propagation vector of this wave function. All right, and this equation is representing a wave traveling in the x direction. All right, now for a free particle momentum, that is p is equals to h cut k and E is equals to h cut omega. It means in case of quantum mechanics we can represent momentum by h cut k and energy by h cut omega. Okay, so we can use this momentum and energy later in our derivation. First of all, what we need to do, let's say this is equation number 1. So what we need to take is to double differentiate equation 1 with respect to x. All right, so by taking first derivative, we are getting iota k a e iota kx minus omega t, and then we need to differentiate again. Then it will be iota k a exponential iota kx minus omega t. From here we got iota multiplied by iota square is equals to minus, and we are getting k square a e iota kx minus omega t, and this is the value of double differentiation of x. All right, now this term is again equals to our equation number 1. So can be write it as, so this equation can be written as minus k square psi, right? And this is again value of this one. This is our equation number, let's say this is equation number 2. All right, now we know that energy is equals to p square over 2m, and we can write this, the value of p from this particular equation. Let's say this is set of equation number a. All right, so by using equation number a, we can write down the value of, what's the value of p by using equation number a. So we got that h cut k square over 2m, where p square over 2m is equals to h cut square k square over 2m. All right, now what we need to take psi on both sides in above equation, right? So we are getting p square over 2m psi is equals to h cut square k square psi. All right, and this is equation number 3. Now what we need to use, so by using equation number 2 in equation number 3, we can use the value of curly square psi over curly x square. So we can write the value of k squared psi, okay, from equation number 2. So what we are getting, p square over 2m psi is equals to minus h cut square over 2m curly square psi over curly x square. This is equation number 4. All right, now what we need to do is to differentiate. Now differentiate again equation number 1 with respect to, this time we need to differentiate with t. So we are getting curly psi by curly t is equals to minus iota omega psi. All right, so this is the value we are getting, and this is equation number 5. Okay, now what we need to do is to take iota h cut on both sides. It means we need to multiply with iota h cut in case of equation number 5 on both sides. So we are getting curly psi by curly t is equals to minus iota omega iota h cut psi. All right, and again I'm getting iota here, which is iota square is equals to minus 1 minus minus plus. So we are getting h cut omega psi, the value of h cut curly psi by curly t. Now here we are getting h cut omega, and we have already discussed that h cut omega in case of quantum mechanics is E, energy. So we can replace this h cut omega with energy. So we are getting iota h cut curly psi by curly t is equals to E psi, right? And this is my equation number 6. All right, now what we need to do is to take generalized situation. Okay, so we now generalize this to a situation in which there is both kinetic energy and potential energy present in the system, then E is equals to p square over 2m plus v of x, right? It means potential in this case is applicable only along x-axis. Now what we are taking psi on both sides, E psi is equals to p square over 2m psi plus v of x psi, right? And let's say this is my equation number 7. Now by using equation number 6 and 4, okay, in equation number 7, 4 and 6, in equation number 7 what we are getting, first value of E psi is equals to I attach cut curly psi by curly t is equals to p square over 2m. We have already got in equation number 4, that is minus h cut square over 2m minus h cut square over 2m curly square psi over curly x square plus v of x psi, right? This is the Schrodinger's wave equation in one dimension, right? Okay, so we can also rearrange this equation, minus h cut square over 2m curly square psi over curly x square plus v of x psi is equals to iota h cut curly psi by curly t. This is in, this is time dependent wave equation in one dimension, right? In which particle is moving only along x-axis, and in 3 dimension this equation is written as minus h cut square over 2m curly square psi over curly r square plus b of r psi is equals to iota h cut curly psi by curly t. This is Schrodinger's time dependent equation in 3 dimension. Alright, so this is about time dependent wave equation. And what about time independent Schrodinger's wave equation? So let's take this second one is time independent Schrodinger's equation. Alright, so this case, that is time independent Schrodinger's wave equation, is very important special case of Schrodinger's equation. And in this situation where the potential energy term does not depend on time, so this case will cover most of the problems. In this case, potential energy or potential is only depend upon position, that is x. So we can write psi, that is xt, is equals to psi x only, because in this case potential is not depending upon time, right? Then Schrodinger's equation becomes, so we know that psi xt is equals to a exponential iota kx minus omega t. Now we can write this right hand side equation as a exponential iota kx and exponential minus iota omega t. Alright, this is my equation number 1, having value psi xt is equals to a exponential iota kx and exponential minus iota omega t. Now here we need to consider, okay, so here consider a exponential iota kx as psi naught. So equation 1 becomes psi xt is equals to psi naught exponential minus iota omega t, and this is equation number 2. Using, now what we need to do is using time dependent Schrodinger's equation, what we are getting, minus h cut square over 2m curly square psi over curly x square plus b of x psi is equals to iota h cut curly psi by curly t. Alright, this is equation number 3. Now double differentiate equation number 1 with respect to x. Again same pattern we are following as we have followed in case of time dependent Schrodinger's wave equation, right? So curly square psi over curly x square is equals to minus curly square over curly x square psi naught exponential minus iota omega t. Alright, and this is equation number 4. Now differentiate equation number 2 with respect to time, and what we are getting, curly psi by curly t is equals to minus iota omega psi naught exponential minus iota omega t. This is equation number 5. Okay, now by using equation 4 and 5 in equation number 3, alright, in this equation what we are getting, minus h cut square over 2m curly square psi naught over curly x square exponential minus iota omega t plus b of x psi naught exponential minus iota omega t is equals to iota h cut minus iota omega psi naught exponential minus iota omega t. Alright, and this equation can be written as minus h cut square over 2m, okay, curly square over curly x square psi naught exponential minus iota omega t plus v of x psi naught exponential minus iota omega t is equals to, we have iota square and minus as well, so this will become plus, and we will get plus h cut omega exponential minus iota omega t. Now we are getting this term in right hand side as well as left hand side, so we will this term will be cancel out. We have left with minus h cut square over 2m curly square psi naught over curly x square plus v of x psi naught is equals to h cut omega psi naught. This is one dimensional time independent Schrodinger wave equation. So this is one dimensional time independent. And how this is time independent? In this case potential energy term is not depending upon time as we are taking this psi naught. Okay, alright, Schrodinger's wave equation, that is minus h cut square over 2m curly square psi naught over curly r square plus b of r psi naught is equals to h cut omega psi naught, and this is time independent Schrodinger equation in 3 dimension. Okay, so we can rearrange this equation, and by rearranging this equation, above equation, let's say this is my equation number 6. So by rearranging, what we are getting, curly square psi minus h cut square over 2m curly square psi naught over curly r square, or only if we are taking x-axis x square plus v of x psi is equals to e psi h omega is equals to e. Now curly square psi naught over curly x square minus 2m h cut square v of x psi is equals to minus 2me over h cut square psi. What we are taking this term towards right hand side, right? And we have left with curly square psi naught over curly x square plus e minus b 2m over h cut square psi is equals to 0. Okay, this is a time independent Schrodinger's wave equation, also written as psi naught over curly x square plus 2m over h cut square e minus v psi is equals to 0. This is Schrodinger's wave equation in 3 dimension. Okay, and this is also a 3 dimension equation. So this is how we can find out Schrodinger's wave equation, which are applicable for number of applications. Thanks for watching this video. If you have any question, you can comment below. Thank you so much. I'll see you in the next